Okay, column with one end fixed and other end is free. First of all, consider a column. Consider a column of length. Consider column of AB of length L 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 of length L. Critical load applied at B. Critical load applied at B. The column one end fixed and other end free. So due to critical load, column 1 will be buckle. As shown in figure. Consider section x1. Consider section x1 at a distance x from A. Buckle at xx1. Is y, is small y. Okay, and buckle at free end is small a. Okay, so now moment at xx, xx1, so we need to calculate moment here. Okay, sorry, moment here. Okay, so moment m is equal to moment is force into perpendicular distance. So perpendicular distance means this distance, it will be, we must be known this distance. Okay, so this one. Okay, this one means it is under the load up to here. So this distance, it will be, so total it is a minus this y. So it will be a minus y. So in bracket it will be a minus y. You can write down it is pa minus py. Okay, this one it is pa minus py. Okay, see here, this one it is y. So a minus y, it will be pa into py. Okay, so now Macaulay method says that ei is equal to it is d2y by dx square, d2y divided by dx square divided by dx square divided by dx square. So moment is equal to, it is m. Okay, so just put all this value here, moment value. So d2y by dx square. So d2y divided by dx square d2y by dx square is equal to m it is PA minus PY minus PY. Okay, so divide by EI on both sides, on both sides, on both sides, on both sides. Okay, it will be get on this equation. Okay, so EI d2y 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 divided by dx square divided by dx square dx square dx square is equal to, sorry, divided by, it will be, so this one it will be is equal to PA minus PY divided by EI divided by EI EI EI. Okay, so now you can write down this one in that way. d2y 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 divided by dx square divided by dx square dx square dx square is equal to you can separate this one, PA divided by EI PA divided by EI divided by EI PA divided by EI, then minus PY divided by EI 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 EI. Okay, so just take d2y 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 divided by dx square divided by dx square dx square dx square plus 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 py divided by ai py divided by ai. Take py divided by ai, it is left side. Pi is equal to it is pa divided by ai pa divided by ai pa divided by ai. Okay, so this one it is pa divided by ai ai ai. Okay, so this is quadratic equation, sorry, this one it is, so write down. So solution of the differential equation is differential equation is solution of the differential equation is this one, it is differential equation. Okay, so you can write down now y is equal to a a a cos in bracket a cos in bracket x x x x root of p by a root of p by a root of p by a. So p divided by ei root of p by a p divided by ei p divided by ei bracket close plus b sine in bracket b sine in bracket x x root of root of p by a 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 P by A, P by A plus A plus A plus A plus A. Okay, plus A. Now apply the boundary condition. So apply boundary condition. Boundary condition. Boundary condition. When when x is equal to 0, when x is equal to 0, comma y is equal to also 0, y is equal to also 0, because of at end it is fixed, there is no deflection at a, so that's why x is equal to 0. When x is equal to 0, deflection it is also at a is 0, so y it is equal to 0, 0 is equal to a cos x root p by a, cos x it is 0, so this term it will become 0, so cos 0 it will be 1 plus 0. Okay, so plus this one it is a, so capital A is equal to it is minus a, minus a. Okay, capital A is equal to minus a. So second apply boundary condition. So this one, write down this one, it is equation number 1, equation number 1. So differentiate with respect to x. So differentiate 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 with respect to x, equation 1, equation 1. So y it is dy by dx, 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 dy by dx is equal to, is equal to, so a cos x root of p by a it will be, so first of all, so root p by a it will be, so minus 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 minus, so why I have written minus, because derivative of cos it is minus sine a. Okay, so root of, so it is constant, it will be take root of p by a, 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 then sine, sine, so derivative of cos it is minus sine. Okay, so minus sine, so I have written minus here, into x, root of p by a, root of p by a, root p by a, root p by a. So root p by a it will be differentiate with respect to x, again it will become ei. Okay, so that's why I written here ei. Okay, then plus, then plus again write down root p by a, 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 ei, ei. So sine derivative will be cos, cos, cos in bracket, cos in bracket, cos in bracket, cos x, x root of p by a, 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 root 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 p by a. Okay, so x root p by a derivative will be root p by a. Okay, so apply second boundary condition. So I will write down here. Okay, so this equation we will require. Okay, so I will erase this part. So a is equal to minus a. I will put here a is equal to this minus a. Okay, so write down. Next, differentiate with respect to x. This one it is equation number 2. Apply second boundary condition. Second boundary condition. Boundary condition. Second boundary condition. when x is equal to 0, when x is equal to 0, 0, then slope at fixed end it will be also 0. That is dy by dx, it is also 0. dy by dx, dy by dx, dy by dx is equal to also 0. dy by dx is equal to also 0. Okay. So just put all this equation in this equation, 0 dy by dx. Okay. So sin 0 it will be 0 plus plus. So cos 0 it will be 1. So root of so this one constant it is remaining. So here it is a. Can write down here it is a and here it is b. Okay. So this one b root of p by a, root of p by root of p by root of p by ei, root of p by ei, root of p by ei. Then cos 0 it will be 1. Cos 0 it will be 1. Okay. So b is equal to, it will be, when we take this side, so b it will be is equal to 0. Okay. So b is equal to, it will be 0. b is equal to, it will be 0. Okay. b is equal to 0. So put a is equal to minus a and b is equal to 0 in equation 1. In equation 1. In equation 1. In equation 1. Okay. This one it is equation 1. Okay. So I will write down here this one. So y is equal to a, it is minus a, then cos in bracket, x root of p by a, root of p by a, p by a, p by a, p by a, bracket close, plus b it is 0. So this term it will be 0 and plus a. Okay, plus a. So simplify this equation. Y is equal to a minus a cos of in bracket x root of p by a, root p by a, root p by a, root p by a, p by a, bracket close. Take a common. So y is equal to, it will be a in bracket 1 minus cos in bracket x root of p by a, 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 p by a, p by a, p by a, p by a. Okay. So apply the second boundary condition. Apply the second boundary condition. So boundary condition. When x is equal to L, when x is equal to L and y is equal to a, Put this one in this equation. So this one, it is equation number 3. Put in equation number 3. Put in equation 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 3. So y is equal to, it is a. A is equal to a in bracket, in bracket, in bracket 1 minus, in bracket 1 minus, 1 minus cos in bracket, cos in bracket x minus root of p by a, 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 p by a. This a, it will be get cancelled. This a, it will be cancelled. So now this a, it will be cancelled. So 1 is equal to 1 minus cos cos x root of p by a, 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 p by a. So can say cos x is equal to, it will be L. So we are taking it is x is equal to, this one it is L. So we take x is equal to L. Okay. Yeah. So cos in bracket, cos in bracket, L root of p by a, 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 p by a, p by a, p by a is equal to, so cos L root p by a, it will be taken left side. So 1 minus 1, it will be get 0. Okay. So it will be get 0. So now write down L root of p by a, root of p by a, root of p by a, p by a, p by a, p by a is equal to, yes sir, okay. So is equal to, it is cos inverse 0, cos inverse 0, cos inverse 0, it is L divided by root of p by a, 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 p by a, cos 0, it is equal to pi by 2, pi by 2 plus comma 2 by pi 2 into then 3 pi by 2, 3 pi by 2, 3 pi by 2, 3 pi by 2, then next comma 5 pi by 2, 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 5 pi by 2. So take list from this, list from okay, so it will get one value. So L root of P by E P by E P by P by E P by E is equal to pi by 2 is equal to pi by 2 pi by 2. Squaring on both sides now. Squaring on both sides. Squaring on both sides. Both sides. Squaring on both sides. It will get L square. L square. L square divided by P by E P by E L square into P by E P by E P by E is equal to pi square by 4. Pi square divided by 4. Pi square divided by 4. 4. 4. Write down P is equal to this. P is equal to this. Pi square. Pi square. Pi square into EI into EI divided by L square divided by L square divided by L. So this one it is divided by L square. Pi square EI by L square. Okay. So this one it is repeating loads for pi square EI by L. Okay. Then one end it is free and second end it is fixed. For that, Euler's crippling load it is pi L square divided by pi L square divided by it is 4 it is remaining 4. Okay. Pi square EI by 4 L square. Okay. So this one it is Euler's crippling load when one end is fixed and the other end it is free.